Here, in the heart of Silicon Valley, we find the headquarters of FUJIFILM Dimatix. From a casual glance, this business campus looks much like any other office complex in the surrounding area. A closer look, however, hints that something extraordinary is going on within these buildings. And that something extraordinary is these silicon wafers that has enabled the miniaturization of electrical circuits, which in turn has opened the door to our modern lifestyle. From this a little over a half-century ago to today's handheld devices with exponentially increased computing capabilities at a fraction of the size and cost. At FUJIFILM Dimatix, we have developed thin-film piezoelectric crystal with unparalleled performance, which we integrate onto silicon wafers to make us a recognized leader in the field of piezo-silicon MEMS. And it's piezo-silicon MEMS technology that is leading to breakthroughs in exciting new applications such as internal navigation, 3D medical ultrasound, and production inkjet printing. Remarkably, if you were to watch for materials going into the Dimatix MEMS fabrication or fab, the only raw component you would find would be 6-inch diameter silicon wafers. Sawn from a single crystal, forged from high-purity sand, and controlled to tight thickness tolerances, these wafers are typically only 650 microns thick. That's less than 2/3 of a millimeter. But not all wafers are the same inside. Borrowing a trick from the semiconductor industry, some special wafers called SOI, or silicon on insulator wafers, have a thin layer of silicon dioxide buried inside. This buried layer has a special purpose, which we will show you later. Converting these silicon wafers into miniature masterpieces is what silicon MEMS is all about. There are 5 classes of operations. No tour of a clean room is complete without first gowning up. Many of our machines use cassettes and robotic handlers to speed up operations and to minimize breakage. We spin coat a photoresist film. And then bake it. Now that we have the 3 wafers with the critical features, we will use a fusion bonding process to produce a single monolithic silicon structure. First, all 3 wafers need to be aligned in relation to each other. A wave propagates through as the wafers come into intimate contact with each other, before going into a 1100 degrees Celsius furnace where the fusion will occur. For dirty operations like grinding, our wafer stack must leave the clean room via a pass-through.
After the silicon MEMS structure is completed, then we sputter on the piezo actuator that actually provides the motion for the device.
It doesn't look like much from the front, but a peek at the backside reveals why this is one of our most sophisticated pieces of equipment. Now, all of the print head features are complete. Over 20,000 inkjets per 6-inch wafer. We here at FUJIFILM Dimatix are committed to creating products that meet the most demanding technical specifications. Packaging the die into a functional printhead is just as crucial to ensure optimal performance. Now that we've assembled our printhead, let's take it for a test drive. At FUJIFILM Dimatix, we don't wait for the future. We're too busy bringing the future one step closer.